All right, today we're going to learn a new skill. It's going to be naming ionic compounds. So before we start, I wanted to make sure that you have a couple things out. One of them is your guided notes. We're on Chapter 5 guided notes now. And we're to the part on the guided notes where it talks about naming ionic compounds. We talked about in the last video, in the last class period, we talked about ionic bonds. Ionic bonds occur between a metal and a nonmetal. So we're going to talk about metals and a nonmetal and how to name those compounds. Okay. Well, the staircase here. What does the staircase separate on the periodic table, guys? Metals and nonmetals. Everything below the staircase. So all of these guys are what? All of these guys. What are they? These are the metals. And everything above the staircase, all of these guys is what? Those are the nonmetals. And also hydrogen's really a nonmetal, right? The reason it's over here is that it has one valence electron. I want to make sure before we start today, though, that you have a few things labeled. What charge does this group 1 form if it forms an ion? +1. What about group 2? +2. What about group 13? +3. Group 14? Plus or minus 4. Group 15? -3. Group 16 is -2. Group 17 is -1. And group 18 is 0. Okay? The noble gases will not form an ion. And so that's going to be very important to have before we start today. So there's one thing that I wanted to show you that I kind of forgot in the previous videos. So, and I want you to write this in on all of your periodic tables. Zinc, we know that it's going to form a +2 charge. Silver, we know forms a +1 charge. And we know that aluminum's in this column or this group that has +3, but I always like to write +3 in this one anyway. So I want you to kind of outline these elements. Okay? So we've got silver +1, zinc +2, aluminum +3. The other transition metals here, we don't know their charge. But for silver, it's always +1. For zinc, it's always +2. Okay, and I always just remember that because it kind of forms a little staircase. +1, +2, +3. Okay. All right, so let's get to it. Naming ionic compounds. Chemical nomenclature. This is just a way to name compounds. This is a system that's used worldwide so that all chemists, no matter what country you come from, has a systematic way of naming a compound so that everyone calls that compound the same name. So there's some rules to this system. Number 1, you're supposed to write down in your notes, the first rule is you name the cation followed by the anion. So you always name the cation first. This is the metal. Okay? Then you will name the anion, which is the nonmetal. So take a second and jot rule number 1 down. So you name the cation first, then you name the anion. Rule number 2, for cations, use the element name. So for cations, you just keep whatever its name is, look it up on the periodic table. So for example, if it's Na, what are you going to name it? Sodium. And you don't change it. So you don't change the name of the cation. Just leave it the same. Okay, third rule. For anions, you use the root name of the element, but you change the suffix to IDE. The suffix is the last part of the name. It's the part that comes at the end. You're going to change that ending to IDE. So for anions, you're going to just change the end of it to IDE. Maybe the most famous ionic compound there is this one. How would we name this one then? Na is what? sodium. Do we change the name at all? Nope. We just named that cation sodium. Whatever it is on the periodic table, look it up. Don't change its name. What's Cl? Chlorine. How do we change the name of chlorine? Chloride. Good. So it'd be, we change that suffix. Instead of "ene", now it's "ide". Sodium chloride. Okay, and that's kind of the rules that we're going to use. Rule number 4. You have to fill something out here. When the compound contains a polyatomic ion, we talked about these last time. You have a polyatomic ion table. That's another paper I hope that you have out today. This yellow paper I gave you last time, please have that out. And we're going to be using it today. Okay, so polyatomic ion table, that paper that we passed out last time in class. In fact, I want you to take it out right now, and we're going to write something on the top of it. Okay? Rule number 4 says, when the compound contains a polyatomic ion, you name the cation followed by the name of the polyatomic ion. We don't change the name of it. So put across the top, don't change the name. So across the top of your polyatomic ion table, put don't change the name. So we don't change its suffix to IDE. We just, whatever it is on that table, we keep it the same. Okay? And that's rule number 4. All right, there's one final rule. Rule number 5. It says transition metals and tin and lead have more than one possible charge. It could be +1, it could be +2. So you write the charge of the element in parentheses. The charge of that element is also written in Roman numerals. So we're going to use Roman numerals to represent the charge of transition metals and tin and lead. Rule number 5 we'll get to in the next class period. For this class period, we're just going to focus on these first 4 rules. Okay? All right, so let's get started. I think it's pretty easy to show you. It's kind of hard to explain. So we're going to go through a lot of practice problems today. I promise if you stay with me, you'll catch on pretty quickly. At least I hope. Okay. So when we name an ionic compound, we're going to start with the cation, which is the metal. So if it's lithium, how do we change its name? Well, we don't change its name. It's just lithium. So the first one that you name the metal, for example, if it's sodium, well, we keep it sodium. We don't change anything about the name. Okay? If you can look across here, all of the names of the ion name, it's exactly the same. So that's easy. Just keep it the same. But for the nonmetal or the anion, okay, for the anion, we do change it. The suffix gets changed to what? Instead of fluorine, now what is it called? Fluoride. Okay, instead of chlorine, it's called chloride. Instead of bromine, it's bromide. Iodine gets changed to iodide. Iodide. Oxygen's kind of a funny one, so let's go through that one. Oxygen gets changed to what? Oxide. Okay, and then there's sulfur, gets changed to sulfide, nitrogen to nitride, phosphorus to phosphide. So on all of these, you'll notice we just change the suffix to IDE. So if it's above the staircase, we change its suffix to IDE. All right. This flowchart, it's a great flowchart, but I don't know if you like flowcharts. It's useful maybe, but I think as we go through some examples, we're going to understand exactly what it's saying. So let's just start and go through some practice problems. Practice problem number 3. It wants us to name the following ionic compound. Okay, so let's name it. Grab your periodic table. What is the name of Mg? It's magnesium. Magnesium. Do we change its name at all, guys? Nope. Keep it the same. What is Cl? That's chlorine. How do we change its name? Yeah, we changed the suffix to IDE. So this is going to be called magnesium chloride. Okay, now you might be wondering, what do we do with this little 2 down here? What is that? We'll talk about that later, but it has nothing to do with the name of this compound. Okay. Magnesium chloride is the answer there. Okay, let's see if you guys can try number 4. Please try this. If you're watching the video, hit pause and try this on your own. And once you have your answer, hit play and see if you got it right. Okay, guys, Na, what is it? Sodium. Yep, just look it up on the periodic table. It's called sodium. Don't change its name at all. The O is what?
Oxide.
Yeah, oxygen, but we change it to oxide. Good. So the name of this compound is sodium oxide. Very easy. Practice problem number 5. Again, try this one. Hit pause. Try it. Write down the name and see if you got it right. Okay, Al is what, guys? Aluminum. And what is S? Sulfur, but how do we change its name? Sulfide. So just drop the suffix and add IDE. Aluminum sulfide is the name of that compound. Okay, practice problem number 6. Please again hit pause, try writing the name of this guy, and once you have your answer, hit play. Okay, let's see if you got this one. Mg, what is it, guys? Magnesium. And what is the N? It's nitrogen. How do we change its name? Yeah, nitrogen gets changed to nitride. So that's called magnesium nitride. You might be noticing these numbers, these little subscript numbers. Again, we will talk about them later. But as far as naming this compound, those numbers don't come into play. So, all right, good job. Hopefully we're getting this down. Practice problem number 7. Now let's name this one. Okay. What is Ca? Calcium. Don't change the name of the metal, the first one. O is what? Oxygen. How do we change its name? So the name of it is calcium oxide. All right, now we're going to change gears a little bit. So hopefully you have your polyatomic ion table out. Okay, it says to name the following ionic compound. What does it say above where you wrote just barely? On top of your polyatomic ion table, you wrote something. What did you write? Don't change the name of these guys. So when we name it, Na, what is that? That's called sodium. Now, OH, you can look all day long on the periodic table. You're not going to see any element that's called OH. Because this is more than one element. It's more than one atom. So it's polyatomic. It's got 2 of them here. So whenever you get to a compound and it's got 2 of them, here's how you will name it. Get out your polyatomic ion table and find it. Which one is OH? What's it called? Hydroxide. Do we change its name? No, just write hydroxide. So the name of this compound is called sodium hydroxide. Sodium hydroxide. So these are actually even easier, aren't they, guys? Naming these, we don't have to change it to IDE at the end. Just keep it the same. Okay, let's try this one. If you're watching the video, try naming it, hit pause, and once you got a name down, then hit play and see if you got it right. Okay, so let's see if you got this one right, guys. What is K? Potassium. Okay, we don't change its name at all, just name it potassium. Now, we know that this is polyatomic because there's nitrogen and there's oxygen. So there's more than one atom. It's on the polyatomic ion chart that I gave you. Which one is NO3? Okay, NO3 is nitrate. So this name of this compound is potassium nitrate. Practice problem number 10. Let's just go through this one kind of quickly. What is Na? Sodium. And we know that this one has to be polyatomic because we've got a sulfur and we've got an oxygen. So polyatomic, let's go to our polyatomic ion table. What is SO4? SO4 is sulfate. Do we change its name at all? Nope, just write it down. So this one is called sodium sulfate. All right, one more. This one's a little bit different. Okay, is this one polyatomic? Does it have more than one atom? It does. Is this one polyatomic? Yeah. So in this case, we've got two polyatomic ions. Do we change the name ever? No. So what is NH4 on your polyatomic ion table? That's called ammonium. And what is SO4? Sulfate. So that is called ammonium sulfate. Okay, now we're going to talk about the significance of a chemical formula. So we're going to look at the little numbers that are written as subscripts below the symbol. So a chemical formula uses chemical symbols. So we know what the chemical symbols are. For oxygen, it's O. For sodium, it might be Na. To identify the element. But it also uses a subscript to show how many atoms of that element are in the compound. So, for example, when you see H2O, H means what? Hydrogen. This little 2 tells us what? That there's 2 hydrogen atoms here, right? There's 2 of them. What does the O tell us? That it's an oxygen atom. If there's not a number, always in chemistry, they never write ones. Ones are always implied. So if there's not a number here, how many oxygen atoms do I have? 1. But they never write the 1. It's always implied. So there's two hydrogens and 1 oxygen. Okay. So, but let's talk about this. How many water molecules would this have? The molecules is given by this number out front. It's called a coefficient. Again, there's nothing written. So how many water molecules do I have? Just 1. The 1 is implied. What if it was like this? 2 H2O. How many water molecules would I have? 2. The number of compounds or molecules is given by this number out front. Okay. All right. So we're not focusing on that one anymore. I'm asking you about this one. How many hydrogens are here? 2. How many oxygens are here? 1. It's implied. How many total atoms are there in this molecule? There's 3. There's 2 hydrogens and there's 1 oxygen. Okay, now this one wasn't asked in the notes, but let's go over it. What if there was 2 H2O molecules? How many hydrogens would I have now? So if there's 2 molecules, how do you get the total number of hydrogen atoms? You times these 2. So hydrogens, you have 4. How many oxygens would I have? 2 times 1 is 2. Okay. And so that's how it would change. Okay, practice problem number 12. It gives us this molecule here, C8H18, and it's got some questions for us. How many compounds are here? The compounds, again, is given out front. How many is there? 1. If there's nothing written, it's an implied 1. Number 2, how many carbon atoms are here? 8. Correct? And how many hydrogen atoms are here? 18, yeah. This little subscript 18 tells us there's 18 hydrogens. Okay. So hopefully the chemical symbols make sense to us now, because we're going to need them going forward. Okay, practice problem number 13. It says, answer the following questions concerning the following compound. Now we've got a little bit different. This is a polyatomic ion, and it's got parentheses around it. And then it's got this 3 on the outside of the parentheses. Well, that changes things a little bit. So let me go through this one with you. Number 1 says, how many compounds are there? What's the number out front? It's a 1. Again, 1 is understood or implied in chemistry. Number 2, how many aluminums are there? How many aluminums do we have, guys? 2. Okay. Now this is where it gets a little tricky. How many sulfur atoms do you guys think are there? Sulfur is right here, and it's got a subscript of 1. But, guys, whenever you see these parentheses, and you see a number on the outside of the parentheses, like this 3 gets distributed to everything on the inside. Distributed meaning that you times it by the subscript that it has already. So how many sulfurs would I have right there? 3. Correct. So we take this 3 and times it by 1. That tells us that there's 3 sulfurs. Okay, let's see if you guys got this one. How many oxygen atoms are there? 12. Correct. 3 times 4 is 12. So you would actually have 12 oxygens. Okay, now this wasn't in the notes, but I want to throw this one in there. What if it looked like this? 2Al2 parentheses SO4 parentheses 3. How many aluminums would I have? Aluminums, I've got 2 times 2, which would be 4. Okay. How many sulfurs would I have? Well, this 3 gets distributed, so 3 times 1 is 3, but don't I also have 2 of these guys? So 2 times 3 is what? 6. Okay, now I want you guys to answer how many oxygens are there. What do you think? How many oxygens do we have? Well, this 3 gets distributed, so there's 12, but then do we have to times it by 2? We do, so what is that? 24. And so that's how that number out in front, it's, again, this is called a coefficient. That's how a coefficient would change that. So. Okay, very good. So far to this point, we have been doing the formula and changing it into a name, correct? We use those rules, it's pretty easy. Now, we're going to switch gears a little bit and we're going to go from the name, and I want you to write the formula. Okay? It's a little trickier, so pay attention. There's a little bit of a trick to this. We're going to use the crisscross method. I'm going to say that a lot for the rest of this video. Crisscross method to determine the compound's formula. So, practice problem 14. It says, determine the formula for the following ionic compound. Now, whenever it gives you a name like this and it just writes out the name, I want you to think about writing the charge of that element above its name. So please have out your periodic table. Aluminum, let's find it. What charge does aluminum form when it forms an ion? +3. It's in group 13. So, guys, right above the name, I want you to put +3. Right above it. Okay, well, oxide is really for which element? Oxygen. What charge does oxygen form? -2. Yeah, it's in group, what group is it? 16. All of those guys form a -2 charge. Okay, now this is when we do the crisscross method. This crisscross method says to take the number above this element and you're going to move it down here. But you're going to take the number of this element and move it down here. So we crisscross it. See where we crisscross? But here's the important thing to remember. We only bring down the number. Do we bring down the sign? No. So this minus sign here does not come with it. The plus sign does not go with the 3. Okay? So now when we write the formula, it's pretty easy. What's the symbol for aluminum? Al. What number goes here? A 2, because that 2 came down by the aluminum. What's the symbol for oxygen? O, so write a capital O. And what number goes as a subscript by the oxygen? 3. A 3. Okay. Pretty easy? Okay, I want to pause for a second and tell you the significance of the crisscross method. It makes it easier for us to balance the charges. Because when ionic compounds form, their charges have got to sum to 0. Well, if aluminum is plus 3, how many aluminums do we have here? 2. What's plus 3 times 2? Isn't that plus 6? Okay. Oxygen is a minus 2. How many oxygens do we have? 3. So what's a minus 2 times 3? That's a minus 6. Do they sum to 0? Yeah. And so if you don't want to use the crisscross method, you just got to realize that the numbers that go here have to work out so that they sum to 0, because ionic compounds will sum their charges to 0. But if you use the crisscross method, it works every time. Okay? There is a little trick, though, we'll show you coming up. So the answer is Al2O3. Okay, let's go to practice problem number 15. Let's do the same thing. I want you guys to try this one now. Determine the charges, write it above the name, then do your crisscross, and write its formula. So hit pause if you're watching the video, try it on your own, and then hit play once you have an answer. Okay, so let's complete this one. Magnesium, guys, if you find it on the periodic table, magnesium is in group 2. So what's its charge? Plus 2. Always tell me whether it's positive or negative when you're putting the charge. What's the charge of fluorine? Yeah, it's in group 17. All of those guys are a negative 1. Now what do we do? Crisscross, right? So do the crisscross method there. Magnesium's symbol is what? Mg. What number comes by the Mg? Do I bring down the sign? Never bring down the sign. The 1 comes down, but in chemistry, do I have to write a 1? Nope, it's implied. So let's just move on. Mg, and then we got fluorine. The symbol for fluorine is F. And what number goes by the F? A 2. So it's just Mg, F2. And if you want to check yourself, the charges should sum to 0. Plus 2 times 1 is plus 2. Minus 1 times 2 is a minus 2. And so they sum to 0. Okay. So Mg, F2. Okay, practice problem number 16. Try this one on your own. Okay? When you're finished, hit play and see if you got it right. So hit pause. All right, let's see how you did on this one. Calcium, what did you guys get for the charge? Yeah, it's in group 2, so it should be a plus 2. Oxygen, what's its charge? Minus 2. Okay, then we do our crisscross method. We bring them down and crisscross them. Calcium's symbol is what? Ca. What number comes down by the Ca? A 2. Oxide is for oxygen, so we write a capital O. And what number goes by the O? A 2. Okay, how many of you guys got that? Well, that would be wrong, okay? Now, I want to point out, this is an important point. The crisscross method works great, but after you do it, you should always ask yourself, can it be reduced? Can the numbers be reduced? Can 2 and 2 be reduced? Yeah. By reduced, I mean, are they both divisible by each other? And the answer is yes. 2 divided by 2 is what? 1. And so both of these can be reduced to a 1, and so it goes to CaO. Okay? Maybe I should talk about reduce. Can I reduce this sequence of numbers, 2, 10, and 4?
Yeah.
What would they reduce to? 1, 5, and 2. Okay, so can I reduce this sequence of numbers? 3, 15, and 21. What would it reduce to? 1, 5, and 7. Okay? Can I reduce, let me find some more space. Can I reduce this sequence of numbers? 2, 1, 10. No, because 1 is already as low as it can go, so we can't reduce that. Okay, so when I say, can you reduce a 2 and 2, I'm asking, are they divisible with each other? And yes, you could both divide them by 2 and get 1. So, and the reason for that, calcium, if you look at it, is plus 2 charge times 2. That would give you a plus 4. It's just not reduced. And so the other one would be a minus 4. But anyway, always when you use the crisscross method, it's very helpful. It shortens our thinking up quite a bit. But ask yourself, can it be reduced? Okay. All right, let's go on to practice problem 17. Try this one. It's got a little bit of a trick to it as well. Try it on your own. Hit pause until you're finished. When you got an answer, hit play. Okay, let's see how we did with this one. Potassium, if you've got your periodic table, potassium is in group 1. So what's its charge?
1.
Plus 1. Okay, now you can look for a long time on the periodic table. Is there an element called hydroxide? There's not. So what does that tell you? It tells you that it's not an element by itself. It must be a what? It must be a polyatomic ion. So this one you're going to have to look up on your polyatomic ion table. Yeah, if it's not on the periodic table, that's just a clue that it's a polyatomic ion. Hydroxide, what is its charge? So look on the table, and its charge is a minus what? Minus 1. It didn't write the 1 because in chemistry it's implied, but it's got a charge of a minus 1. So now let's do our crisscross method. This one plus 1 comes down here, and this one comes here. All right, potassium symbol is what? K. What number comes by the K?
1.
Yeah, the 1. Do I need to write it? Nope. Okay, so let's move on. Hydroxide, what is its symbol? Yeah, it's OH. What number comes by the OH? A 1. Do I need to write anything? Nope. So that's it.
No, put the negative thing by it.
No, you don't. You don't ever bring down the negative signs here.
Like this on here.
Oh, on the table? No. That just tells you its charge. Okay. Okay, that is potassium hydroxide. I've got one more like this one, but it's a little bit different. So practice problem 18. This one changes a little bit, so I'd like to go through this one with you. Okay, calcium, what's its charge? Yeah, it's plus 2. It's in group 2, so it's a plus 2. Hydroxide is polyatomic. We just did it. What's its charge? Minus 1. It's a polyatomic ion. Okay, now we do the crisscross here. And now we have to write the formula. What's the formula or the symbol for calcium? Ca. What number comes by the calcium? The 1. Do I need to write it?
No.
No. Now, let's move on then. Hydroxide is what? OH. But now we have a problem. Where does this 2 go? If I put a 2 right here, that means I have 2 hydrogens. But would it mean I have 2 oxygens too? No, it wouldn't. And so what they do with polyatomic ions is they use parentheses. Okay? So you're going to have to put parentheses. Whenever this number is not a 1, you need to put parentheses. And where does the 2 go now? On the outside of the parentheses. Because that gets distributed to everything. Does this mean there's 2 oxygens? Yes. And does it mean there's 2 hydrogens? Yeah. And so that's your answer. Okay. So I want you to write on your polyatomic ion table, I want you to write this. Let's just write this. Always use parentheses. spell S-E-S, right?
Yeah, it's S-I-S.
S-E-S.
P-A-R-A-N-T-H-E-S-I-S.
S-I-S? Anyway, always use parentheses, okay? Put parentheses around that. Put that on your polyatomic ion table. Guys, whenever you're doing the formula, always use parentheses when writing the formula. Okay. Now, you might think to yourself, well, we didn't use parentheses on practice problem 17. So let's go back there. Do I need parentheses if the number on the outside is a 1? No. Could you use parentheses? Could you write it K parentheses OH? Yeah, I guess you could. But nobody does that. So if it's a 1 on the outside, you don't need parentheses. But if that number is a 2 or a 3 or any other number than 1, you've got to use parentheses because that distributes to everything on the inside. You've actually got 2 of the hydroxides. Okay. All right. Okay, I've got a couple more practice problems and then we'll be done with this video. Practice problem number 19. It says, write the name and the formula for the ionic compound that would form from the following elements. So if we had zinc and we had iodine, and we combine them, what would the name be and the formula? Okay, so take a second and see if you guys can get that. The name and the formula. Okay, let's see if we got the name right. Do we change the name of the metal at all? Nope. So it's just zinc. How do we change the name of the nonmetal or the anion? Yeah, the INE is going to get changed to IDE. So it's called zinc iodide. Okay. Now let's get the formula. If the name is zinc iodide, what do I always write above the name? The charge. What's the charge of zinc? Always a +2. What's the charge of iodine? -1. Let's crisscross it. Okay. Now when you write the formula, zinc is Zn. What number goes by the Zn? Just a 1. Do I need to write it? Nope. Iodine is I, capital I. What number goes by the I? A 2. Can I reduce a 1 and a 2? Nope. So there's your answer. The name is zinc iodide and the formula is ZnI2. Okay, I've got one last one. Practice problem number 20. Again, I want you to write the name and the formula of the compound that would form if you combine zinc and sulfur. All right, so the name. Do we change zinc at all, guys? Nope. We don't change the name of the metal at all. Sulfur is a non-metal, so we're going to change it to what? So it will be called zinc sulfide. Good. Okay, if its name is zinc sulfide, what do I write above the zinc? +2. What's the charge of sulfide? Sulfur is a -2. It's in group 16. So if we do the crisscross here, okay, zinc is Zn. What number goes there? A 2. Sulfur is capital S. What number goes by the S? A 2. Now, whenever you use the crisscross method, what do you ask yourself? Can it be reduced? Can I reduce a 2 and a 2?
Yeah.
Yeah. So let's reduce it, and that goes to what? Zn1, S1. Do I need to write the ones?
Do you have to show that you've reduced it?
Yes.
You do?
Well, I guess you don't have to show that you've reduced it, but if you wrote this on the test, you're going to get it wrong. Okay? So I'm looking for the reduced form, always. Okay. ZNS would be the answer. Okay. Guys, this is naming ionic compounds. Again, a metal and a nonmetal. When they form a compound, they form an ionic bond, and we call that an ionic compound. Hopefully we've learned how to name them. And so hopefully you've got through that and it all makes sense, and hopefully that helped.